force and laws of motion. In this section, we are going to discuss about balanced and unbalanced forces. Before discussing about balanced and unbalanced forces, let us see how we calculate net force acting on a body. When the forces act in the same direction on the body. Suppose these two people are carrying an object and the force applied by these two people is acting on this body in the same direction. Since they are taking this object in this direction, therefore they are applying the force in the same direction. So, when the forces act in the same direction on the body, then net force acting on the body is calculated by adding these forces. That is, F is equals to F1 plus F2. Suppose F1 is 25 newtons and F2 is 20 newtons. Then, according to this, the net force acting on this object comes out to be F is equals to F1, which is 25 newtons, plus F2, which is 20 newtons. Therefore, total force, that is net force acting on this object, comes out to be 45 newtons towards right. Since the force is a vector quantity, we need to give the direction along with the magnitude of force. So here, the direction of motion is towards right. Now, what happens when the forces act in the opposite direction? When the forces act in the opposite direction on the body, the net force on the body is calculated by subtracting these forces. Now, suppose these two people are pulling the hands of this man. So, the forces applied by these two people are in the opposite direction on this man. Therefore, the net force will be calculated by subtracting these two forces. F1, say F1 is the force applied by this boy on this man, and F2 is the force applied by this girl on this man. Then, the net force we get is equals to F1 minus F2. Now, let us consider F1 is equals to 25 newtons. And its direction of application is towards left, and F2 is 20 newtons and its direction of application is towards right. So, the net force according to this formula comes out to be F is equals to F1, that is 25, minus F2, that is 20. Net force comes out to be 5 Newton. And the direction of motion would be towards left. Since the greater force is acting towards left, this person will move towards left. Therefore, the net force will be 5 Newton towards left. Now we will learn what are balanced and unbalanced forces. Let us see what are balanced forces. If the forces equal in magnitude acts on a body in opposite direction, then the body will not move. Such forces are called balanced forces. Let us consider it with an example. Consider a box is tied with strings X and Y on opposite ends. Say a force F1 is applied towards left, then this box will move towards X, that is towards left. And suppose a force F2 is applied on this box, then this box will move towards Y, that is towards right. Now, suppose two equal and opposite forces, that is F1 and F2, are applied on this box, then this box will not move. Why? Because the forces that are applied are equal in magnitude. Therefore, the net force comes out to be 0. In previous section, we have studied when two forces are applied on a body in opposite direction, then net force is given by F is equals to F1 minus F2. Since here F1 and F2 are same as F1, that is, they are equal in magnitude, when we will subtract two equal magnitude forces, the net force comes out to be 0. Therefore, this box will not move, it will remain at its own place. Thus, we can say that these forces are called balanced forces. Now, what are unbalanced forces? If the force is unequal in magnitude acts on a body in opposite direction, then the body will move towards the greater force. Such forces are called unbalanced forces. Let us see the example again. Let us consider this box again, which is tied with a string X and Y on the opposite sides. Let us say that force F1 is applied on string X and F2 is applied on string Y. If F1 is greater than F2, then this box will move towards F1, since someone is pulling this box with greater effort on this side. That is why F1 is greater. Therefore, the box will move towards left. Therefore, these forces are called unbalanced forces. Suppose F2 is greater than F1, then what will happen? This box will move towards F2, since F2 is greater than F1, and again the forces are unbalanced forces. What will happen if F1 becomes equals to F2? Then the condition that we have already studied of balanced forces will come into picture, where the net force acting on the body will become 0 and the body will not move. Now let us consider a live example of balanced and unbalanced forces. In this example of tug of war, you will see that when the forces applied by these two people are equal and opposite, then it will remain at the center. However, when the forces applied by one of them becomes greater, then the other person will move towards the one who has applied the greater force. Let us see. See, till the time they have applied same force, that is equal force, it remain at the center. However, when the force applied by this person, say F1, becomes greater than the force applied by this person, say F2, that is when F1 becomes greater than F2, then the other person started moving towards right. Therefore, we can say that tug of war is an example of unbalanced forces. Students, we have studied about unbalanced forces. We have studied that whenever unbalanced forces are applied on an object, then it results into its motion towards the greater force. That is, if this is an object on which a force of 5 Newton is applied towards left and a force of 2 Newton is applied towards its right, then this box will start moving towards the greater force, that is 5 Newton. Thus, we can conclude application of unbalanced forces results into the motion of the body towards the greater force. Here, another force comes into picture, that is friction. In this section, we are going to study about frictional force and what are the examples of frictional force. How do we define friction? We define friction saying the force that opposes the relative motion between the surfaces of two objects in contact is friction. It acts along the surfaces in contact. Frictional force always acts in the direction opposite to that of motion. That is, if the motion is taking place towards right, then friction force will act towards left. Let us consider an example to understand friction. In this example, you will see that some force is applied by this person to move this box. But this box does not move and it remains at rest. He will try again and again to move this box, but it remains at rest. This happens due to the frictional force balancing the force applied by this person. Say, if the force applied by this person is F1, then the frictional force, which is acting opposite to the direction of the force applied by this person, is balancing it and resisting this box to move. But as soon as the F1, that is the force applied by this person, becomes greater than the force of friction, this box will start moving. Let us see. See, this person is trying to move the box, but he fails again and again. But as soon as the force applied by him becomes greater than the frictional force, he is able to move the box. Therefore, we can say if F1 is less than Fr, that is, the force applied by the person on an object is less than the frictional force that is acting along the two surfaces in contact, then the object will remain at rest, and it will continue to be at rest in the condition if F1 is equals to Fr. But as soon as F1 becomes greater than Fr, that is, the force applied by this person becomes greater than the frictional force, the body will start moving. Therefore, frictional force opposes the relative motion. It is resisting the motion of this box, and it occurs between two surfaces in contact. That is, here the two surfaces are the surface of this box and the surface of the ground on which this box is lying. And frictional force always acts in the direction opposite to that of motion. Here, this person was applying force in this direction. He was trying to move this box ahead. Therefore, the frictional force acts in the opposite direction. Let us consider some more examples of frictional force. Students, have you ever thought, how do we move? In this example, we have considered a person walking on the ground. Here, the two surfaces are lower surface of this man's feet, and another surface is that of ground on which this person is moving. So, this surface. So, there must be a frictional force acting between his feet and ground. If this person is moving ahead, that is towards left, then the friction force will act in the opposite direction of motion, that is towards right. In order to move, this person has to apply a force, say F1, which is greater than Fr, which is friction force. Hence, we are able to move when we apply a force which is greater than frictional force. Let us see. See, he is able to move because he is applying a force which is greater than frictional force. Students, you must have also observed that on certain surfaces you feel slippery, and on other surfaces it gets harder for you to move. This is all because of friction, because the surface on which you feel slippery offers less friction. Therefore, the force applied by you to move ahead becomes so greater that you fall down. And in case on the surfaces on which you feel harder to move, the friction is so high that it gets harder for you to move ahead because you apply more and more force in order to overcome the frictional force. Thus, friction force helps us in walking. Other example of friction force is cycling. How do you cycle? While cycling, the surface offers friction force to the tires. That is, if you're moving in this direction, then the surface in contact, the surface of this wheel and the surface of this ground will offer a friction force in the opposite direction of motion. And when you apply a force greater than that of a frictional force, then you are able to move ahead. See, since this girl is applying a force which is greater than that of frictional force, she is able to move ahead. Another example of friction force is a falling leaf. A falling leaf also experiences a friction force. Surface of air offers a friction force to the falling leaf. These are few examples of frictional force.